Example 3. A stone is thrown from the top of a vertical cliff, which is 30 meter high at a speed of 15 meter per second at an angle of 32 above the horizontal. Find the time for which the stone is in the air. B. Find the distance between the base of the cliff and where the stone lands. Okay, so for this question, or if you want to sketch a diagram for this, so the stone now is projected 30 meter and fly in this way in a projectile motion, then touch on the ground. Right, so the angle of projectile will be 32 degrees. So for this question, find the time for which the stone is in the air. So if you question asking this way means you need to calculate the time, okay, just at the instant that the stone, okay, touch on the ground. So you may set your initial condition. Okay, so initial condition U will be equal to 15, theta 32, G, okay, for this one also negative 10, and when you touch on the ground, Y, the vertical distance equal to 0, and the height that originally achieved is H, I mean the starting position is 30 meter. Okay, this one not so important, but depends on how you're going to solve it, right? So now we will put inside the vertical distance equation in order to calculate the timing. So how you going to do that? So if you want to put this one, you will put the vertical distance equal to 0, then ut, u mean 15 sine 32 t, and plus half, this one you can put 10, or some of you put the 10 in here also can. Negative, I mean negative at the plus area also can. If you don't want, you just put at the negative at the behind, and t square. Okay, look at this. Now this equation, this one I should put y here first. I put y here first. Y. Okay, I put y here. Okay, now this is a general equation for vertical distance. So based on the drawing at the beginning, so if you want to find, okay, the distance when its vertical distance equal to 0, so how are you going to solve it? So I will go back to the graph. Graph is like that, and touch on the ground. So this is the point that you be projected. Okay, so how you gonna do? So if your reference point is the starting point, I mean at the height of 30, so if you want to calculate this, you may do another way. Means if you consider this point, the displacement at this point, at the ground point, actually the displacement is negative. I mean the vertical displacement is negative 30, right? So if you want to calculate the t, you may put the y equal to negative 30. Okay, so the y is negative 30, but if your reference point is at the ground level, okay, so your y should be 0. So depends on you how you're going to solve it. Okay, so let's say I just use the values that my reference point is the starting point, so my y will be negative 30. Okay, so now I can group my equation again. So negative 30 will be equal to 15 sine 32 t sine 32t, okay, minus 5t squared. So by simplify this, you may get a quadratic equation t squared minus 3 sine 32 t minus 6 equal to 0. Right. So when you proceed to do this, as usual, you have to show how you get the t. So in the exam, you have no choice. Cannot factorize means use the quadratic equation. Okay. So by consider this, if you solve it, you will this one you can use the calculator to check the answer, but you must show. Okay. So by showing this, you have a t 1.780 and t equal to 3.37. Okay, so you have 2t, so and in a normal situation t cannot be negative, so your possible answer will be t. Your only answer is t equal to 3.37 seconds. So only this answer. Right. B. Find the distance between the base of the cliff and where the stone lands. Alright, so you have the t already, and you need to know, actually this is a range. Okay, so the range, so that you know that x is equal to u cos theta for the range t. So u is 15, cos 32, right, and multiply 3.370 the time there, or if you can get longer, longer this decimal or exact value from the beginning, you should get the exact value, right? So your range that travel when you touch on the ground will be 42.87 meter. In the final answer you may get 42.9 meter, right? So this is for question 3, right? So question 3 is the case that you project out with a certain height. Okay, so for question 3, now we proceed to question 4. Question 4, Shasha is practicing basketball in her garden. She released the ball from a height of 2 meters at a velocity of 10 at an angle of 40 above the horizontal. On its distance, it lands in a net that is 3 meters above the ground. Right. For how long was the ball in the air? And B, how far away from the base of the net was Shasha standing? Okay, so if you want to do this question, you may, depends on you. You want to sketch first. For me, I will sketch first. Easy to see. So this one, what that, you should draw a proper. You may draw a proper parabolic. Okay, so 2 meter at the beginning. Maybe this is the net area 3 meter. Right, the projectile. So for this question 1, for how long was the ball in the air? So for this question, you know that the net is 3 meter from the ground, and another one is 2 meter from the ground. So from this basic scenario, you know that the net, the displacement, vertical displacement now is the difference between these two. So the vertical displacement is 1 meter. So you may group a vertical displacement equation. Vertical displacement y equal to 10 sine 40 t. G is negative 10, so you have minus 5t squared here. Okay, half 10 squared, so minus 5t squared. And you know the difference of these two level is 1 meter, so means the vertical displacement is 1 meter. You can put 1 here for y, and 10 sine t minus 5t squared. Right, and by solving this, you should get the t accordingly when you reach on the basketball net. Okay, so you should get t equal to 0.1899, sorry, 1811. And another one you will get t equal to 1.104. So for these cases, so which answer you should choose? Right, and you know that this is a parabolic, so maybe in the 1 meter difference, the t will be 0. This one is t1, this one is t2. So which one will be your answer? Don't forget you need to look back to the original question. So on it descent, okay, descent means at the way to going down. So your answer should be t equal to 1.104 or maybe 4 seconds, or you may give your answer 1.1 seconds. Alright, so your answer is this only. Okay, so that one is when the way of ascent going up. So the question tell you going down. So answer only 1.1 second. So B, how far away from the base of the net was Shasha standing? Or similar things, you need to find the range mean the distance that you hit on the target. Same things, you will use the basics formula x equals to u cos theta t, and you will have a 10 cos 40. Time will be 1.104. Okay, so if you calculate this, you should get something like 10 cos 40 times 1.104. Okay, you get 8.457 meter, right? So it's about, if you want to give a correct answer, 3 significant 8.46 meter away from the net, right? So this is the answer for part B. Right, so should be okay, right? Very basics formula they will use in the calculation of projectile motion, right? So for this chapter, actually if the question give you numbers, okay, should be very not difficult to calculate, but there are the situation, a lot of situation that they ask you to prove something that without numbers, right? So they will ask you to use so-called unknown and variables to prove something or to show something. The basic principle will be same, just how you're going to proceed to show the equation and prove the equation, right? So all the background knowledge will be same, just because the student will become how to say, confused when they're using uh, unknown or variables to show something. So you have to practice also, no choice, because they are the situation that ask you to show, right? So we go for the some basic formula that you will use, you may need to prove in the exam, but depends on the values or some particular values that given in the question. Okay, and in your exam they will in the formula booklet they will give you a formula called projectile or maybe called trajectory equation. The equation is in terms of y equal to x. Okay, y in terms of y equal to x, something like that. So you will have something y equal to x. If you giving you x, you can find y. You give y, you can find x accordingly. But you need to know how to prove it. So we go for some basic proving for these chapters. Okay, so first they may ask you to prove the time of flight for particular returning to the same height. I mean same height will mean same height to the starting point. Okay, so how to prove it? If they go to the same height, normally we will consider the vertical scenario. So we go back to the basic formula will be y equal to ut sine theta minus half gt squared. Okay, so for this part, this is the original equation that you have without values, but you know g is 10, right? So if the question asks you the time, means the vertical motion will be 0. Go back to the basic one. Go back to the original position. Okay, this one we consider displacement. So you will have this general formula. So if you rearrange the formula, you will have t u sine theta minus half gt, okay, equal to 0. So in this equation, they already consider the acceleration as a deceleration already, the gravity. So they put a negative there. So for this question, you will have 2t, t equal to 0, or t equal to 2u sine theta over g. Right, so in this situation, if you simplify again, if you take it up, not simplify, t will be equal to 2u sine theta over g. Alright, so t equal to 0 means the starting timing, and t equal to 2u sine theta over g will be the time for the particle to return to the original position, alright, original height. So this one they may ask you to prove, and you will need this one this time to show the trajectory projectile motion equation, right? Okay, so this is first part. Second part, the question may ask you to show the range, ask you to prove the range, and you already know this is the total time for you to travel back to the original position. So if you want to find the range, you need to sub this value to the x equals to ut cos theta equation. Okay, so we pause it, see what happened. So x equal to ut cos theta. So we sub the general equation for t, for the range, the total timing inside here. So what we have u 2u sine theta over g and cos theta. Right, so this one from previous part, and this one is g, not y. Okay, so we continue, simplify. So you will have x equal to 2u square sine theta cos theta over g, and you simplify some more, you have a u square sine theta sine 2 theta over g. Right, 2 sine theta cos theta equals to sine 2 theta. So this is equal to the range. So your range will be equal to u square sine 2 theta over g. Right, so this one how to derive? Okay, so you have to derive from the total time, and this one sub back to the horizontal velocity equation, and you will get the range. Okay, so this one, the second one, range. So now third one, here first. The one they may ask you, prove the maximum projecting angle is 45 degrees. How to prove it? So you know that R is equal to U square sine 2 theta over G. And if you want to find the maximum range, okay, so that you need what angle you need to projector in order to achieve the maximum range, right? So you need to differentiate. dr d theta will be equal to 2u square cos 2 theta k g. So if you want to get the maximum, this one you put 0. And this one 0, you know that u already constant because you have the fixed things, g constant, and only the theta you can change. So in order to achieve the different range, so now you can solve. So cos 2 theta will be equal to 0, and 2 theta will be equal to 90. So theta will be equal to 45 degree. So if we want to achieve maximum range, your theta, your projectile theta should be 45 from the horizontal, 45 degrees from the horizontal. So if you sub this 45 degrees to the original range equation, see what happens. So R equal to U square sine 2 theta over G. This is the range equation, and you sub 45 inside, so you will get R equal to U square over G, right? So this is the maximum range. So it's not you not need to care about the theta. If you want to find the maximum range, you just take the original velocity, square it, and divided by the gravitational acceleration, so will be your maximum range. Okay, so this is the things that you need to know. Okay, so how the question asks you to prove, we don't know, but this is the skill that all link together, right? So you can see that all will be go back to the original equation. You don't need to memorize the equation, but you just know the step to prove, because the question may ask you in a different way. Okay, so now we go for the next part. Next part will be the greatest height that achieved. Okay, so you know that v equal to the vertical velocity, v equals to u plus at, u sine theta minus gt, right? So u plus at. So if you want to have a maximum height, okay, the greatest height, so when at the greatest height is a turning point, so v will be equal to 0. So you have a u sine theta minus gt equal to 0 at the maximum height. So from here, you rearrange, you will get t equal to u sine theta over g, u sine theta over g. So this is the below is g. So this is the time for the item to reach to the maximum height. So if you sub this value inside the vertical displacement equation, now we put inside and see. So y equal to u sine theta t minus half gt square. So if you sub the t just now inside here, you will have u sine theta over g sine theta minus half g u sine theta g square. And if you simplify, okay, you simplify it and you will and combine it, you will get y equal to u square sine square theta over 2g. Right, so This is the maximum height equation. The general equation for maximum height. You need not need to memorize, but you just need to know how to derive. Okay, so this is the maximum height equation. So means you know the velocity, initial velocity, you know the angle, and you just sub inside, you will get the y. Okay, the maximum height. Okay, so this is the things that you need to remember: maximum height. And the last one will be the equation of path of the trajectory, or maybe we call projectile path equation, right? So now we clear this one first. Okay, and you know that for the horizontal speed, for the horizontal velocity, x equals to u cos theta t, right? Okay, so you simplify, t will be equal to x u cos theta. So this is a time that travel. Okay, but at the particular moment you have a particular x displacement. So if you sub this one, the t, inside the y displacement equation, ut u cos theta psi theta. Oh, I have not enough weight. I use another page. Y equal to u x u cos theta psi theta minus g over 2 t squared. Right, and simplify it, you have a y equal to x tangent theta minus gx squared theta over 2u squared theta cos squared theta. Okay, so this one you can simplify some more. Y will be equal to x tangent theta gx squared secant squared theta 2u squared. Okay, so in some situation they may the equation may change this one to tangent only. So if you change to tangent only, you just use the identity. So gx squared, this one minus, okay, 1 plus tangent squared theta over 2u squared. Right, so this is the equation for path of projectile. So actually it's not difficult. You just sub the total, the t in terms of x, then put inside here, so you remove all the t and you will get, so at the end you will get x tangent theta minus gx squared multiply 1 plus tangent squared theta divided by 2u squared. So this one, actually this equation is inside your formula booklet. You open and see, but you need to know how to apply lah. But you need to know because come from where. Because sometimes they ask you to prove, and sometimes they may ask you to they give you a general equation. So you compare this, they give you a general equation, right? And you compare the general equation and this. You know the component of x, and you know the component of u, or you know the component of theta, right? So they ask you to find directly from the equation, right? So you need the general equation compared to the equation that given in the question. So in compare this way, you may able to direct get the mark, because sometimes they will just give you, okay, find the x. For example, they give you 2 tangent theta, okay, minus a constant multiply 1 plus tangent 2 theta. So they ask you to find the x, right? So you can compare directly and you can find the x directly. If not, then you need to derive from the beginning, then you will take a lot of time. right? So this equation, you may play around, and this one is given in the formula booklet. You may play around to change the theta to tangent to secant or to cos accordingly. The question will play around like that. So later you will try the question and you will know that actually it's not difficult, just compare. Most of the question in your past year is compare, right? Derive, sometimes they ask you to prove, but not difficult. Okay, so we go to example 5, right? Example 5. Example 5. Two stones are launched from the same place, ground level, and land at the same point on the ground. The first stone is launched at angle of 40 degrees to the horizontal with a speed of 28. The second stone is launched at an angle of 55 to the horizontal. Find the greatest height attained by the second stone. Okay, so how are you going to do that, this question? And although you can use the equation for the motion for projectile, but it's quicker that you use the range for the greatest height directly from the formula range that uh, is given by x equal to u square sine 2 theta. Okay, this is not given in the exam. It's not in the formula booklet. So for this kind of question, depends on you. I think the simple way is to memorize this equation. Okay, you may get from the very basic formula for component x and component y, and from that you may able to solve it. Okay, we'll see. If we give you this, we directly compare, you should able to get the answer. So for this, you have for the first stone, you have the speed of 28 at an angle of 40. The range will be equal to 28 square sine 80 over 10. Okay, so the range. For the second stone, you have an initial speed of u and the angle is 52. Okay, so I clear it, not enough space. For the second stone, you have u square sine 110 over 10. Right, and you know that the range is same, so you can put equal to 28 square sine 80. Okay, so when you have this formula, you can directly apply. If you don't have, you just very maybe one or two more steps derive from the beginning. Okay, so I did not ask you to memorize it. If you can, we derive from the beginning. Okay, so solve it. You will get you will know that u square will be equal to 28 square 80 over sine 110. Okay, so once you have this, you may able to find the greatest height attained by the second stone by direct apply the equation. What is the equation just now? The greatest height will be equal to u square sine square theta over 2g. So you may directly put inside and see what is the answer. Okay, so we see. So h equal to u square sine square 2 theta over 2g. Right, and just now you have a u square already. Just now you have a u square, so you have a 28 square sine 80 sine 110 multiply sine square 55 over 210. Right, so for this one, you will get the greatest height is 27.6 meter. Right, so when you know the final equation for the greatest height, range, you may be faster, but if you ask you to memorize the equation, I think it's not fair to you, because you have a lot of equations. You can't memorize each one. So as I say, it's good to derive from the beginning. And when you want to apply this equation, sometimes the question will give you, then you use, no harm. Okay, so I think the easy way is not memorize the equation each by one, but you know how to derive is more important. Okay, because the question may give you different form of the equation, so uh, you can't memorize everything, right? So the concept you have to understand. Okay, so this is for question 5. Okay, so today assignment is very simple. Today assignment is very simple. So you just submit. You just submit the working solution for sample question part 1, question 1. Okay, sample question part 1, question 1. For others question you may proceed to do. You have part 1, part 2 and part 3, right? You can proceed to do, no issue. And you just need to submit the working solution for part 1, question 1 to the link. Okay, so we clear the chapter the part 1 for chapter 1. Okay, Friday we will go for the part 2 for we will go through some question for chapter 1. Okay, some sample questions, and once we done we will move to chapter 2, right? Okay, thank you.